All right, and we are back to talk about gene mutations. So we just went through the process of protein synthesis, and that's going to bring us up to sometimes that doesn't go perfectly. Sometimes it's misread. Sometimes there's a mistake in transcription. Sometimes there's a mistake in translation. And we're going to talk about what happens if there is a mistake. So what are the possibilities of what could happen in the event that there was a mistake in any of these processes? Now remember, the mistake could happen in DNA replication, it could happen in transcription, it could happen in translation, it could happen almost anywhere. So we're going to talk about what could happen, what are the side effects if it does. So one thing to keep in mind through all of this is that when we are reading mRNA, it's read in groups of 3, and those groups of 3 are called codons. So we're going to talk about we're gonna equate it to reading a sentence where all the words have 3 letters. That way it'll make sense. So the first sentence that we have here, the normal one, is why did the red bat eat the fat rat? That sentence makes sense. Makes pretty good sense. Why did the red bat eat the fat rat? However, what would happen if we made some type of change? So let's look here at this first one. What was the change here? The change here is that there is a C instead of a B. So our sentence changed. Why did the fat red cat eat the fat rat? Now that still makes sense. There was a change, but it still makes sense, so that's probably okay. Now let's look at number 2. What happened here? Here, there used to be an E, but the E got deleted, so the E disappeared. Let's see what that did to our sentence. Why did the red bat at, hef, at? That does not make sense. That's not good. If this happened in our bodies and it didn't make sense anymore, that would not be good. All right, well, let's look at number 3. Let's see, what's the change that happened in number 3? Well, here we have an A that was added. So we added an A. An A was inserted. Let's see what that does to our sentence. Why did the red bat eat at Ephatrata? That messed it up again. That cannot be good if that happens in our bodies. So these are some of the consequences that can happen. If we're reading in groups of 3, which is done in translation, we read in groups of 3, some changes, like in number 1, it didn't make that big of a deal. It was okay. It still made sense. But changes like that happened in number 2 and number 3, adding and deleting, those had really, really bad consequences. And they would make huge differences. Those would be probably negative mutations happening in our body. So about mutations, just in general, remember a mutation is a permanent change in the DNA sequence of a gene. Mutations in a gene's DNA sequence can alter the amino acid sequence and thereby damage the protein. These can happen during errors in DNA replication, it could be an error during transcription, and sometimes they are random and they're caused by exposure to chemicals, UV radiation, or different carcinogens. So sometimes they are random. And there are different types of mutations that can happen. We saw a little bit about that in our first slide with our sentences, but now we're going to give them names. So we could have changes, a single base change. So that would be if there should have been an A, but now there's a U, or a G changed to a C. one letter change to another letter. And that could lead to 3 different things. So it could be a silent mutation, which would be if nothing happened at all, the word stayed the same. The amino acid chain didn't change, everything was the same. So that's just like nothing changed at all. There could be a missense mutation, and that would happen if the letter changed. So maybe now we have a different word, the amino acid is different. And the last one is a nonsense mutation. Nonsense mutations happen when one letter changes and now we have a stop codon. So what that means is that the protein would be stopped early. Now, if our protein is supposed to be this long, but it stops early and now it's this long, that protein cannot do its job. It is not functional, and that would be a very large change. So of these 3, nonsense is going to be the worst mutation because we wouldn't even have a full protein. Our protein would be really short. A missense mutation would change the amino acid, but maybe we could still be functional, might be okay. A silent mutation would not matter at all because everything is perfect, it's still the same. So those are things that happen if we change just one letter. So one letter changes to some other letter. However, kind of like we saw above in numbers 2 and 3, if we add or delete something, that's going to change the entire reading frame, meaning it changes everything that happens after it. Meaning that whole protein is going to be completely messed up and different after that point. So again, you could have frame shift insertion, where a random letter is added, or a deletion. If you add or delete something, that's going to change our groups of 3 from there on out. And everything is going to be different, and that can be quite negative when our whole protein changes to something else. Now that's going to leave us with a question. Is there any value in mutations? That's an interesting question. I'm going to throw this one up on a discussion board. Is there any value in mutations? You guys can discuss that.